Hey everyone, it is Mr. Vargas here, as promised, looking to help out Math 8 with homework 6.4 dilations on page 491. Just want to go over a few of the problems from your homework assignment. That way you can complete that and get it turned in. Here we go. We've got number 2. They give us this shape RSTU, and they give us the coordinates. First thing you probably want to do is map out those coordinates. Let's go ahead and do that. So R is 1, 1. Let's make that here. S is 1, 7. Right there is my S. My T is 5, 7. Right up there. And my U is 5, 1. So it looks like we have a nice square happening here. Okay. We are asked to dilate this shape by a scale factor. Oh, it's not a square, sorry, this is a rectangle. But we are asked to dilate this shape by a scalar factor of 3/4. Since this number, since k is less than 1, that means we're going to be shrinking our shape. We're going to shrink our shape by a scale of 3/4. So, just like Mr. Morrow taught us, all we have to do is multiply each of these coordinates by our scalar factor to get our new shape. So let's go ahead and do that right on down here. If I take R, 1 times 3/4 is just 3/4. And once again, 1 times 3/4 gets you 3/4. So that's my new coordinate, my R prime, my image. Okay, and let's go ahead and do S really quick. Well, if I take 1 times 3/4, that would get me 3/4, comma. Okay, now a little bit trickier. If I take 7 times 3/4, what I really am doing is taking the 7, multiplying it by the 3, and writing it over the 4. So, here we go. 7 times 3 is 21 over 4. Easy peasy. That's my S prime. My T prime is going to be 5 times 3 over 4. So that would get me 15 over 4 for my X coordinate. A little sloppy there. Okay, and then we already did a 7. 7 times 3/4 gets you 21 over 4. Okay, and then last, my U prime becomes 15 over 4, comma 3 over 4. So once again, we just multiplied by our scalar factor. Quick little side note, if you're thinking about these improper fractions and you're kind of confused on what they are, well, if I do top dog in the house, bottom dog sleeps outside, that would get me 5 with a remainder of 1 over 4. And then that would be the same here, 5 and 1 over 4. And then 15 over 4. Well, I know that 4 goes into 15 3 whole times with 3 left over. So there's your mixed number. And once again over here we can do that. So 3 and 3/4. That's going to help us when we go to plot our new points. Let's go ahead and plot it. R prime is 3/4, comma 3/4. So that's probably right about here. That's about 3/4, and then up to 3/4. That's going to be our new shape. Let's do it in this color. So R prime goes here. Okay, now let's graph 3/4, comma 5 and 1/4. Okay, so 3/4 over and then up 5. 1, 2, 3, 4, 5, and then 1/4 is probably right about there. I'm just going to guesstimate. Okay, so that's S prime. Alright, next is T prime. We've got 3 and 3/4 and 5 and 1/4. So let's do that. We start out in the middle. We go 3 right, 1, 2, 3, and then about 3/4 away is going to land us right there, close to the 4, but not quite. And then up to 5 1/4. Get you back up here, even with that last S. So right there, let's go ahead and make that point. Right there. Okay, that's my T prime. Okay, and then the last thing that I need to do is 3 3/4, comma 3/4. So start here, go over 3, 1, 2, 3, and 3/4 would be right about here, and then up to 3/4 should line up nice with that R prime. So this is going to be my U prime. And there's our new shape right there. We definitely shrunk that original shape by 3/4. Got a little bit smaller. Excellent. Let's move on to the next problem. Alright, number 4. Let's do number 4. Darian wants to build a regulation size pool table that is 9 feet in length. Okay, so let's go ahead and just draw a pool table. Get that pictured. So this might look something like this. Okay. And we know that it is 9 feet. 9 feet in length. The plans he ordered are 18 by 36 inches. What is the scale factor of the dilation he must use to build the regular pool? Okay, so the plans he got are, let's draw like a mini table, because this is our plans. And the plans are, let's see, 36 long inches and only 18 inches wide. Okay. So we really don't care about this 18 inches. What we're really trying to compare is this 36 inches to this 9 feet, and what's going to be our scalar factor to make our plans change into the real pool table. So this is the real pool table that he wants to build. Okay. First, I would probably want to convert this 9 feet into inches. And in order to do that, I take my 9 feet, and I know that there are 12 inches in 1 foot. So let's take that 9 and multiply it by 12, and you should get 108. So this is actually equal to 108 inches. Okay, now it becomes a little bit clearer. What did we take, or what's our scale factor, our K, for converting 36, the small shape, into the large shape, or the large pool table? So we kind of have an equation here. We've got 36 inches here to 108 inches, so what do we multiply 36 by to make 108 and make that real table? Well, here's an equation, 36K equals 108, and we know to solve that, just divide both sides by 36, and you find that your scalar factor, K, is 3. You can check that on a calculator if you had to, or you could just double check my work. 36 times 3, carry the 1, is 108. So we definitely have the correct scalar factor right here. K equals 3. Alright, good luck on the rest of the assignment, and I'll see you in class.